So today we've got a nice little geometry problem. This is question 1G from the 2018 Oxford MAT exam, and it goes like this. So we're given that the parabolas with equations y equals x squared plus c, for c a constant, and y squared equals x, this is the plus or minus the square root of x, and these two curves, they touch. That means they meet tangentially. They meet at a single point. So we're going to talk about what that means, and then the question is to find what the constant c must be from this information. So let's go ahead and look at this. Okay, so in this question we're given the equation of two parabolas. One is the standard y equals x squared plus c, so this is symmetric about the y-axis, and one is y squared equals x, which is symmetric about the x-axis. And the second one is essentially the square root of x in the first half and minus the square root of x in the second half. So we need to essentially find out how high up this first parabola needs to be, so we have exactly one place of intersection, and at this place of intersection these curves are touching. So by the word touch, this is quite important, it means that they are intersecting in the first place. So we know from this information we can get that for some value of x, x squared plus c equals the square root of x, and we know it's the positive square root of x because we're in the top half. And also we know that they're going to have the same gradients, because touching, it means that they're meeting tangentially. So if we draw the tangent, it's going to be exactly the same for both of these curves. They're going to have the same gradients. And that means if we differentiate both of these functions, we're going to have the same gradient. So derivative of this is just 2x, the constant vanishes, and derivative of the square root of x is a half times 1 over the square root of x. So these are the two bits of information that we derived from knowing that these two curves touch. So the second one here is something we can solve, and this tells us where the position of the intersection is going to be. So if I just bring this over here, we have, rearranging, we have x to the power of 3 over 2 equals a quarter. So I've just divided by 2 and I've moved the square root of x up here. And then solving, this tells us that x equals 1 over 4 to the power of 2 over 3. I've just flipped the indice here. So this point tells us the place of intersection. So this is our value of x. And now with this information, we know where they intersect. We can sub this into our first equation, and this is going to tell us the value of the constant c. So we have that c is going to equal square root of x, which is the square root of this. So 1 over 4 to the power of 1 over 3. I've just gotten rid of the 2 here because we're taking the square root. And then we're subtracting x squared, which is going to be this squared. So 1 over 4 to the power of 4 over 3. If we're taking the square of this, we're just multiplying the power by 2. And then we can do a bit of algebra. We can simplify a little bit. So if we factor out this term, we have 1 over 4 to the power of 3, 1 over 3. Bring this out the front, we can have 1 minus, and then we're essentially just subtracting a third off the power here. And that's convenient because we're just left with 1 over 4. And then we can simplify this even more. Obviously this simplifies to 3/4. So this tells us that our constant c is going to be 3 over 4 times 1 over the cube root of 4. Right, so this is the solution, and just to recap, this tells us the height our first parabola needs to be at, so the y-intercept, this is value c, such that these two parabolas, they touch at a singular point. So they intersect exactly once, not 0, not twice, or infinitely many often. They intersect exactly once, and at the point of intersection, they have the same gradient. So this is our solution. C equals 3 over 4 times 1 over the cube root of 4.